Now we are ready to run the nest while list of COLM of, what is it? Pound. It's always pound there. And then the initial condition is I'm going to use 27, and this time we will try 5. So this is one that had failed before. And then I want to be safe, so I will just have this here. Okay. Would it work? Of course it works in one step. Geez, this is a multiple of 3. So here, if I did this, so all these things are behaving now. It just comes down quickly. So would it really work that way? Let's see. What did I call it? I called it B. I made a function out of it. What was it? All these are extra stuff that I did to make it. So I want to change this number n here. So I will call it n. And then, so I will make a function out of it. That is n as a parameter. And there we go. And in front, I will call it Collatz. Okay. So what I want to see is Collatz of, say, 27. It would just give me this here, right? But what I want to know is the length of it, because I want to know if it converged. And what else do I want to know? I want to know the last term. So I want to know the last guy's first number. Okay, so I will group them. And then, actually, I will do for all kinds of numbers. So I am feeding. Let's produce that first. So I'm doing Collatz of that. Actually, why don't I just produce the list first? So Collatz of n. Or I could do it so many ways. Let's use table. Collatz of n, where n goes from 1 through 100. Okay, I'll call this to be B here. So I will get a whole bunch of lists that is going through the Collatz conjecture. And I'm using 5 here, okay? All right, so what does B look like? Wow, it seems like nobody lasts this long time. Well, okay, inspecting visually is kind of misleading. So from list B here, what we want to know is the length of the list, and we want to know what the last one's first number was. So I will group them as a curly bracket like this. I will call it C, and I will map it. Okay, now this is not telling me. Oh, this is the length of it, and this is the last number. So some of them reached 10, but nobody went too far. You can see here, right? Actually, if I do sort of C, where the first number is bigger than the second number, or the previous number is bigger than the subsequent number, then I get this here. Huh? Why doesn't it do anything? Okay, because it's got 2 numbers. Okay, previous number's first element is bigger than the first number of the second element. Here we go. So cycle of 33 was the biggest one you ever had when you had this here. So now if I feed some more numbers, 1,000 numbers as an initial number, and then you did this, and you did this here, 61 cycle was the biggest one you ever did. That's very interesting, huh? Okay, so here 5n plus 1, they all converge. Now you can get ambitious here. You can put 15, and that's the Collatz of 15. Or I can call it M, and I can have M M here. So here I can enter it now. So okay, let's go with 7 here. So if I start with 7, would it? No, they all converged here. So it is possible. I don't know yet. But now you can see, you can make a chart of N versus M and see which one converges and which one doesn't. And it is possible that they all converge. It is possible that they don't. What we could do is use ever larger number, like 17. Okay, it's taking a while to generate it. Now this is getting promising this time. Okay, this took a while. I stopped. I had paused the recording, and then let's see, sort out. Ah, they bombed out. Okay, so now who bombs out and who doesn't is the intriguing part. So get the pattern of this, and then we'll go from there.